So let's start with why this even entered the conversation in the first place. This didn't come from a late-night rumor or a meme on the internet. It came from someone who spends his life thinking about capital, incentives, and where the world is actually heading. When someone like that floats an idea like this, it's not because it's easy or imminent, it's because the conditions are changing. We're in a moment where the old playbooks are breaking down. Capital is no longer free. Supply chains are geopolitical. AI isn't a feature, it's a force multiplier. And the gap between what institutions say they want to do and what they can actually execute has never been wider. In that environment, people start asking different questions. Not what fits the rules, but what actually works. That's why this landed the way it did. It wasn't framed as gossip. It was framed as logic. If you're already building the most advanced electric manufacturing system on Earth and also the most advanced launch and orbital infrastructure ever created, at some point you ask whether keeping those worlds artificially separate still makes sense, especially when the technologies, AI, materials, energy storage, robotics are already bleeding into each other. This isn't about ego or spectacle. It's about recognizing that the scale of problems we're trying to solve has outgrown the silos we're used to operating in. When survival, sustainability, and expansion all start to overlap, people who allocate capital for a living begin to think less like traders and more like engineers. That's what made the comment land. It wasn't a prediction. It was a signal that the future may require structures we haven't fully named yet. Sometimes the most disruptive ideas don't announce themselves as plans, they show up as questions that refuse to go away. If you step back and really look at it, this was never about running two unrelated companies in parallel. From the beginning, it's been one mission expressed through different machines. One focused on fixing the trajectory of life on Earth, the other on making sure life itself has a future beyond it. Different domains, same underlying problem. How do you extend the probability curve of civilization? On one side, you have sustainable energy, autonomy, and large-scale manufacturing, not as buzzwords, but as physical systems that actually work in the real world. On the other side, you have reusable rockets, orbital infrastructure, and the ability to move mass off the planet at costs that used to be considered impossible. Those aren't separate stories. They're chapters in the same book. What people sometimes miss is that the overlap isn't theoretical, it's already happening. The same first principles engineering, the same obsession with cost curves, the same belief that if you can't manufacture something at scale, it doesn't matter how clever the idea is. Talent flows back and forth. Lessons learned in one domain immediately inform the other. Failures, too. Especially failures. This isn't about diversification for its own sake. It's about focus. If your goal is to maximize quarterly optics, you don't do any of this. But if your goal is to maximize the long-term survival and expansion of intelligence, then you build tools that reinforce each other over decades, not news cycles. Seen that way, the question isn't why these efforts rhyme, it's why anyone ever thought they were separate. One reduces the risk of collapse here. The other reduces the risk of extinction entirely. Both require speed, scale, and a tolerance for being misunderstood for a very long time, same mission. Different gravity wells. Once you get past the philosophy, this is the part where the numbers start to matter. Because beneath all the big ideas, there's a very practical question: does this actually work in the real world? And when you look closely, the synergies aren't hypothetical, they're already showing up in fragments. Take AI and robotics. Training systems to drive a car safely through chaos isn't that different from training systems to land a rocket precisely on a moving target. Perception, decision-making under uncertainty, real-time control, these are the same core problems. The more data, the more iterations, the faster the improvement curve. Progress in one domain doesn't stay there, it leaks into the other. Then there's manufacturing. High volume, high precision manufacturing at absurd cost targets is hard. It's harder than designing the product. Solving that problem once gives you a template you can reuse everywhere, from energy storage to launch hardware to humanoid robots. Materials science, thermal management, supply chain automation. These aren't separate skill sets. They're multipliers. Energy is the quiet backbone of all of this. Cheap, abundant energy storage changes everything. It changes how factories run, how data centers scale, how vehicles move, and eventually how off-planet infrastructure survives. When you control that layer, the rest of the stack becomes more flexible, more resilient. And yes, capital matters. When systems share research, compute, and long-term infrastructure, you don't just save money, you compress time. That's the real advantage. Time is the one resource you can't manufacture. And integration buys you more of it. From an investor perspective, it also changes the equation. Exposure to space becomes part of a broader technological arc, not a binary bet on a single outcome. Risk spreads. Upside compounds. When engineering, energy, and intelligence reinforce each other, and the whole system moves faster than the sum of its parts. Now, this is where every MBA in the room starts quietly shaking their head, because on paper, this breaks almost every rule we're taught about how companies are supposed to work. One side is private, capital intensive, and deeply entangled with national interests. The other is public, highly scrutinized, and judged every 90 days by a market that doesn't love patience. Trying to combine those worlds looks, frankly, insane. The valuation alone will give people heartburn. How do you price something that isn't optimized for near-term profit, but for long-term capability? How do you explain to public shareholders that some of the most important investments won't pay off in years or decades? Traditional finance wants clean lines, clean comps, and clean exits. This is none of that. Then there's governance, different risk tolerances, different disclosure requirements, different political realities. One mistake in one domain could spill over into the other in ways regulators were never designed to model. This isn't a merger where you slap together two balance sheets and call it synergy. It would force an entirely new way of thinking about corporate structure, accountability, and oversight. And let's be honest, there would be resistance. A lot of it. From regulators, from analysts, from people whose job is to maintain the existing order, not because they're bad actors, but because systems defend themselves, especially when something threatens to move faster than the rules can adapt. But here's the uncomfortable truth: the rules were written for a slower world, a world where industries evolved independently, where innovation moved in neat categories, and where the stakes weren't quite so existential. That world is gone. So yes, by traditional standards, this makes no sense. And that might be exactly the point. If you follow this logic all the way to its natural conclusion, you start to see that this isn't really about cars or rockets at all. Those are just the most visible outputs. What's actually being built is a full vertical stack for a future civilization, piece by piece, layer by layer. Energy sits at the base. Without abundant, reliable energy, nothing scales. On top of that comes transportation, moving people, goods, and information efficiently, both on Earth and beyond it. Then AI, not as a feature, but as the nervous system that coordinates everything in real time. Manufacturing turns ideas into physical reality at scale. And finally, space, because no civilization that stays confined to a single planet survives indefinitely. Individually, each of these layers is hard. Together, they become transformative. When they're aligned under one long-term objective, feedback loops tighten. Improvements propagate instantly across the stack. A breakthrough in materials improves batteries, vehicles, factories, and spacecraft at the same time. Advances in autonomy make everything safer, faster, and cheaper simultaneously. That kind of compounding is rare and powerful. This is why comparisons to traditional tech giants miss the point. This isn't about selling devices or capturing attention. It's about building infrastructure so fundamental that it fades into the background the same way electricity or the internet did. You don't argue with it, you build on top of it. At that point, the comparison set changes. You're no longer competing with companies. You're operating at the scale of systems that shape how society function. That's not a claim of superiority, it's a recognition of responsibility. And responsibility is the part that matters most, because when you build at the level of civilization, the goal isn't to win markets, it's to extend the future. Build the stack right, and everything else becomes possible. And this is where the conversation inevitably turns from excitement to unease. Because once you put all of this together, the question stops being about what's possible and starts being about what's appropriate. When one coordinated effort spans energy, transportation, intelligence, manufacturing, and space, you're not just shaping products, you're shaping trajectories. And people are right to ask who gets to steer that. The optimistic view is straightforward. Integrated systems reduce friction. They move faster, waste less, and solve problems instead of handing them off to the next institution and hoping for the best. When everything is aligned around a long-term outcome, you can make decisions that actually compound over decades. That's how you tackle climate risk. That's how you become multiplanetary. That's how you buy time for civilization. But there's a shadow side to scale. Power concentrates. Failure modes get bigger. A decision made by a small group can ripple across entire industries or entire societies. Markets aren't really designed to evaluate that. Regulators are even less prepared for it. They evolve to keep competition fair, not to oversee systems that start to resemble public infrastructure. So the concern isn't bad intent, it's fragility. Any system this large has to be built with transparency, redundancy, and a willingness to be questioned constantly. Because the moment trust erodes, progress stalls, and progress is the whole point. Still, here's the reality most people don't like to say out loud: the future is going to be built at this scale, whether we're comfortable with it or not. The only real choice is whether it's built deliberately, with a long-term view and clear accountability, or accidentally through fragmentation and inertia. This isn't about control, it's about responsibility catching up to capability. The future will be big, so we'd better be worthy of building it.